Brilliant calculus students, I'm going to introduce some basic concepts of the derivative and the integral today. So, this is an introduction to calculus. You need very little background information. I'm just going to introduce very basic ideas of calculus with a story. Okay? So, there's a brilliant person who lives in the mountains. Uh, I'm going to call that you because you're a brilliant person and you will learn calculus. And so this brilliant person knows concepts of calculus. And one day there's horrible storms, right? And so these horrible storms knock over some trees. Boo, the tree is knocked over. Okay, and then it knocks out part of the bridge that he lives. And there's a couple of like little threads, so it's not like dangling off the edge. There's a little thread there. But he can't step over it, but he can't just jump over the bridge. So the storms knock out part of the bridge, and they also knock down some trees, and there becomes a big stump on this grass patch over here that hurts his little goat friends that like to graze over here. So so you want to see how you can get over there to check if your goat friends are okay. And you use the concept of the derivative and the integral, right? So this bridge, we're going to kind of look at it at a side view here, right? So this bridge is kind of like this. It's a bit wavy. It's not a, because you're kind of going up the hill and it's not a regular shape. But, and then there's just this part of the bridge that's gone. And you need to see if you can be able to put a log here that you can set back over. So there's a bit of tree parts left over that you can kind of carry over there. But you can imagine a small little pebble. And you can point the pebble and you can kind of look at the small part of the bridge that's missing. And you can kind of count with your small little pebbles how many far and up the you can count the slope of the missing area. And so you count that it's 4 by 3. And you know that you can walk up anything that is less than 45 degrees. Because if it's just straight up and down, you can't climb a wall. And you can walk perfectly fine on a flat surface. And so the healthy median is 45 degrees. You can walk up that. And you know that this is less than 45 degrees. And so you know that if you place a log here, that it's roughly a straight line at this big curve with a small thing that's missing. This small bit that's missing. It's about a straight line between these really two small points. This between these it's about a straight line between there. So you can just drag the log. So now you've placed the log on top of the bridge. And now you can go check your little goat friends. What you have just done here is the concept of the derivative. You looked at a complex curve that you can't find the slope of, and you zoomed in to where it's basically a straight line. And then you took the slope of that small little area, and you can find the slope. When someone says the idea of a derivative, all they're saying is the slope of a curve. And this idea of zooming in to where the function is straight line, It's called local linearity. When you zoom in far enough, anything looks like a straight line. Now what about trying to see if your goat friends are okay? You go over and examine your goat friends, and you know how much they graze in a year. You want to see if everything is going to be okay for your little goats. You know that how much is in this little patch of grass, and you want to figure out how much the little tree took away. But it's in a regular shape. It's not any normal shape. It's not like a circle or a square that you can easily calculate. It's some weird, funky shape. I'll draw a weird shape over here. And you want to try and calculate this area to make sure that your goats can still survive and you don't have to carry this big tree away. I don't know, this tree is heavier than the other one for some reason. And so you take your little pebble before and you start putting them on here. And you do this. Drew a couple on here so you could get the point. They're not exactly the same size, but I think you kind of understand what I'm doing. They're relatively large, so there's some stuff that goes on the outside over here, and there's a bit of overlap and some gaps on the inside. But what if you took smaller circles, smaller pebbles, right? This would give you less gaps in between and less area if you were able to perfectly line them up. And this could continue to try and calculate the area. And you know the area of the pebble, it's about a circle. It's about the area of a circle. So you can just kind of calculate the number of circles and the area of each circle, and you can find the total area. But you want to be extremely precise. You just start picking up grains of sand. And you can find the area of a grain of sand because that's basically a circle. And so you can start putting grains of sand right next to each other. And you can count every single grain of sand. And you can find basically the exact area that this tree is covered. And this is the idea of the integral. You have the area of one tiny thing, and you keep adding small areas together so that you can find an area of something that is not easy to find the area of. This is common and if you have some function, and you can calculate the length of a rectangle. The idea is you can calculate rectangle with the length and the height, and then you can do the same thing. If you know the length of the rectangle each time, and the height is just the y of the function. This is just the value of the function. You just keep adding these together to find the total area between the x-axis and the function. This is the concept of the integral, finding the area using areas that you can calculate. Thank you for listening to my introduction to calculus.